Hello everybody, it's Mr. A here again for another lesson in geometry. Today we're in section 1.2 and we're going to talk about linear measure. Alright, so let's get started. Our objectives today, we're going to measure segments, line segments, and we're going to be able to calculate using those measurements that we take. Alright, first of all, I guess my line segment here came up first. What you see there is an example of a line segment. Okay, remember before last time we talked about lines and we had arrows on the end of our lines, which meant those lines went on forever and ever. So in this case, if you notice here, we do not have arrows on the end of this line, we just have dots. So this is what's called a line segment. Okay, so it stops, that line segment stops at A and stops at B. So what that means is, since they stop at a certain point, we can measure them because they have two endpoints. Lines we can't measure because they go on forever. So we can measure these, okay? And so if we have a line segment, we can measure it. Okay, so the question is, and now here's where things can get a little bit tricky, but the name of this line segment, remember how we named lines before? We use 2 points, and then we put that little symbol with the arrows on both sides on it. We're going to do a very similar thing here. So the name of this line segment, we would call it A, B, B, with just a line over it like that. Notice we do not put arrows on either end. So this is the symbol when we write this. This is the symbol for the line segment AB, and we use its endpoints, A and B. So we know when we see this, we know it's a line segment going from point A to point B. Okay, no arrows. Now, here's where it gets a little bit tricky, because when you talk about the measurement or how long it is or what's the distance from A to B, the way you indicate that the measurement of something is you just use the letters AB. You do not put any symbol over it. Okay, so it's a little tricky. But remember, if you have AB with the arrows on it, it means line AB. If you have AB with a line over it without the arrows, that's line segment AB. And if you have just AB, it's talking about the measurement or the distance from A to B. Okay? When we measure something as well, if you notice down here, the measurement of a segment includes a unit of measurement. So meters, inches, miles, feet, those sorts of things. Okay, so remember, we're always going to need that. Okay, first example today. We want to find the length of AB. So find the length of line segment AB using this ruler. Okay, so what it's saying is we're going to measure from A to B, and that's the line segment from A to B over here. Okay, now this particular ruler is in millimeters. Some rulers may start measuring at the very edge of the ruler. Some start in a little bit, so you have to be careful. On this one, you notice this is the 0, so it starts in. It does not start at the end of the ruler, but sometimes it does. You notice here, if you know anything about millimeters and centimeters, it's all based on units of 10. So if you were to count these small little spaces in here, there'd be 10 of them up to 10, and again 10 more up to 20, and so forth. And so easiest thing to do here is we go, well, here's starting at 0, go 10, 20, 30, 40, and then what do we got after that? 1, 2. So we could say here the length of this would be 42. 42 what? Remember, there has to be a unit of measurement. Well, it's in millimeters. So we'd say 42 millimeters. Oh, that's bad. Okay, so 42 millimeters. That's an M, by the way. Okay, you get the idea. Now remember, if you know anything about the metric system, remember 10 millimeters is 1 centimeter. So if you were feeling really adventurous here, 10 millimeters would be 1 centimeter, and so that'd be 1, 2, 3, 4 centimeters, and then 2 millimeters, so you could say here 4.2 centimeters if you wanted to. That'd be a fun way to do it. But that's a little extra. Okay, moving on. Number 2. We've got centimeters here. Okay, so now remember, you want to pay attention to if it starts at the end or in a little bit. And you notice again, this one, the 0 point is in a little bit, not right at the end. So here's our 0 point. And we've got 1 centimeter. By the way, remember each one of these little marks in here is 1 millimeter, right? And so we've got 1 centimeter. We don't quite have 2, so it's a little less than 2. Now this line is a little weird here because it's hard to tell exactly where it ends here. But let's do this. Here's 1, and then we're going to count out 1, 2, 3, 4, 5, 6, 7, 8. It could be 8 or 9. You're going to have to use your judgment here. It almost looks like it's right in the middle, but I think it's closer to 8. So I'm going to call this 1.8 centimeters. 1.8 centimeters. Okay, so, and again, if you were to wanted to switch this in your head to millimeters, you could make that'd be what, 18 millimeters. I'd probably stick with the centimeters though. Okay, next. Now we got some inches here. Okay, so now some good old American measurement. Now this is actually kind of an easy one to measure here, but I want to talk about all these little marks in between here mainly. Okay, so well, first of all, if you look at this, here's 1 inch, 2 inches, 3 inches. It goes straight from 0 to 3 inches. So this is pretty obviously 3 inches. Okay, nice and easy. But what I wanted to do is talk about all these little marks in between, because there's a lot of marks there. So if you notice, here's 0 to 1. Well, if you go, well, what would be halfway between 0 and 1 is this one right here. You notice it's not as long as the 0 and the 1 marks, but longer than the other ones. That's 1/2. If you took from 0 to 1/2, what's right in the middle of that? This one. It's not as long as either of those other two, but it's still longer than these other ones here. That's half of a half, which is 1/4. Okay, so let me write this in here. So that's 1/2. That's 1/4. Of course, then this is 3/4, right? And then you go, well, in between all of these here, there's 1, 2, 3, 4 marks inside there. So altogether, there's 4, 8, 12, 16. So if you looked at all the small ones, there'd be 16 of them out to 1. And so each one of these little marks would be 1/16 of an inch. Okay, so if it gets down to one of those small marks, it's going to be in 1/16. Okay, so watch out for how the ruler is marked. That'll help you out a little bit too. All right, next, example 3. Now notice on this ruler, we don't have all those little marks. All we've got are some of these bigger marks, right? Remember what this one was here? That was 1/4, this was 1/2, and this was 3/4, right? So in other words, 1/4, 2/4, which is 1/2, and 3/4. Okay, so let's measure this out. You got 1, 2, and then remember each one of these marks is 1/4 now. So 2 and 1/4, 2 1/2, and this would be 2 and 3/4. So 2 and 3/4 inches. Okay, good. Feeling pretty good with this? All right. So we got down doing some measuring of points. Let's talk about this concept of betweenness of points. Okay, the betweenness of points. All right, if you look at, wow, okay, that was interesting. I don't know how I did that. The betweenness of points. It says point M is between P and Q. So here's M. It's between P and Q if and only if P, Q, and M are collinear. Hey, there's that word again. Remember we learned that last time? Collinear, that means they have to be on the same line. And PM, the segment of PM plus the segment of MQ have to together equal PQ. All right? So whenever they say this word between, that means this has to happen. You have to be able to add these two up to equal the whole length of it. Okay, that's the betweenness of points. All right, so let's take a look at a few things here. Now you notice in this situation, these appear to be all collinear. And so if they're asking for xz, that's the length of the whole thing here, right? There, that's this whole entire length. All right, so if we're trying to find that whole entire length, and these are all collinear, what should I be able to do to find that length? All I have to do is add that one. Okay. I just have to add this one. And I wish this would just leave me alone. And that one. Let me try something here really quick. Okay. I'm not sure why it's a little different today, but so if we add those, we're going to add 4 5/8 and 2 1/2. That's all we have to do is just add those together to find xz. And you notice here they said find xz. There's no line over this, so they're saying find the measurement or the distance from x to z. Oh no. This means we're going to have to add fractions. Oh no. Okay. Not that bad. All right. Here's all you need to do to add these fractions. What I would do is this, and we might have to adjust this one a little bit. We've got 4 5/8. Let's try to make this the 1/2 to be the same as the 8 over here. So what's 1/2 if we had an 8 on the bottom? In other words, what could we multiply both the top and the bottom, or what could we multiply the bottom one by to be 8 and we do the same in the top? Well, times 4, right? And so if we do that on the top, that would be 4/8. Okay, so all we have to do now is we can add the two big numbers. 4 plus 2 is 6. And then remember, if you have the same denominator, you can just add the ones on top. So in this case, it would be 9/8. Ooh, that's a little weird. Okay, well, just remember, we're just going to adjust this a little bit. Remember, if there's 9 out of 8, what would be one whole number? 8/8, right? So we just break up 9/8 into 8/8 plus what? 1/8. Together that would be 9, right? So what's 8/8? That's just 1, and we can add it to that, so this would be 7 1/8. That's one way to do it. The other way you could do it is totally turn these into improper fractions and turn them back. Remember how you would do that is 8 times 4 would be 32, plus 5 would be 37, and you could do 37/8. And then this would be 2 times 2 is 4, plus 1 is 5, so that'd be 5/2. You'd still have to get a common denominator and then add them. I don't think I'm going to go through that whole thing, but you still could then get a common denominator, add the top, and then turn it back into a mixed number. So, oh, one last thing. What did I forget here? I said 7 1/8, but guess what? Don't we have to have a unit of measurement, which is inches? And so I have to write inches in there. Okay, next. All right, in this situation, we're trying to find LM. We're trying to find this one. We know the length of the whole thing. We know this part. Well, how could I find what's in here? Subtract? Good. Yeah, that's all we have to do is subtract. So all I have to do is subtract 4. Have to take this one minus the 2.6. And so I just subtract 4 minus 2.6, and I'll get what? 1.4. And don't forget units of measurement, which is centimeters. Good. So depending on what we're looking for, we might add or we might subtract. All right, one more here. Ooh, fractions again. Oh, why do we have to keep doing fractions? Okay, that's all right. So again, we're trying to find that. We know the length of the whole entire thing is 3. So if we take 3, all we have to do is subtract 1 3/8 to find what's left. Okay, well, how am I going to do that? Here's probably what I would do. Again, you could make these both improper fractions, subtract, and go through all that. But let's do this. Let me just show you kind of what I did before in reverse. 3, think about 3. Could we rewrite 3 to be 2, and then what's left? We still have 1 left if we use 2, right? Well, if I think about it as 8, it would be 2 8/8, right? So this is 2 plus 1 more would be 3. And then if I think of it that way, then minus 1 and 3/8. Now what could I do? 2 minus 1 is 1. And 8 minus 3 is 5. So 5/8. And this would be inches. So 1 and 5/8 inches. Feel okay with that? Moving on. Now it gets fun. Okay, now we're going to have some fun. Okay, this is where it gets fun. We need to now take what we've learned here, write an equation, and then we're going to solve it. So this ties in a lot of stuff. So this is going to be fun. Okay, so let's read the directions here. We've got a lot of stuff. We've got to figure out what's going on. It says find the value of x and st. So there's two answers that we're going to give here. If t is between s and u, so remember t is between s and u, that means it has to be on the same line because it says it's between. St is 7x, well that's already marked over here. And then su is 45. Oh, well that's not marked, so let's write this in here. Su is 45, and tu is 5x minus 3, that's marked. Okay, so first of all, read through this, make sure that you've got all your information in here. All right, now what we want to do is, now remember what our whole thing was here with this kind of problem is this short segment plus this other short segment have to add up to be the whole entire segment, right? In this case, 45. So here's the equation that I'm going to write. I'm going to write 5x minus 3 plus the other segment, 7x, so that plus that has to equal 45. Guess what? We've got an equation. Now we're going to solve it. Okay, so we got to remember our patterns for solving equations. First thing I'm going to do is I'm going to take the x's and I'm going to combine those. I have 5x plus 7x, which equals 12x. I still have that minus 3 there, and I still have the 45. All right, now I'm going to go through the steps to solve. Remember what we start with is we start with getting rid of the subtraction or addition. So since it's minus 3, to undo that, we add 3. If I add 3 to that side to get that to cross out, I also have to add 3 to this side. So I have 12x equals 48. And then the last step is since it's 12 times x, what undoes multiplying is dividing. So I divide by 12 and divide by 12. Those cross out. And so in the end here, x is going to equal 4. Yay! Now, wait a minute. I solved for x, but what did it ask me for? It said find the value of x and st. Oh. So what we have to do is we have to do a little bit more. We know what x is, and so how would I find out what st is? Well, st is this distance from here to here. St says it's 7x, so it says st is 7. Whoops. St is 7x, and so all I do is I put 4 in wherever there's an x. So in this case, it's just going to be 7 times 4, and so that's going to be 28. St is 28, and you know what? In this situation, there are not units given to you, so we can't give the units there. But look for that if you can. But in this case, we're just going to say st is 28 because they don't give us any units of measurement there. Okay? All right, last thing. Almost done. Last thing that we're going to talk about in this section is congruent segments. Main thing here is to know that congruent segments, that word congruent, basically just means things have the same measurement, okay? So if you have, in this little example over here to the side, AB, line segment AB is 1.7 centimeters, line segment CD is 1.7 centimeters. If they have the same length, they're congruent. So how we indicate that something is congruent symbol-wise when we write it out is this right here, that symbol right there. The equal sign with the little squiggly line on top, that means something is congruent to. Okay, so in this case, the way they write this here says line segment AB is congruent to line segment CD. okay, because they're both 1.7. The other way that you may see this on the drawings indicated is if you notice these little red slashes that are through these lines. Even if you didn't know that that was 1.7 and that was 1.7, if you see these red little slashes through the lines, that tells you they're equal. You may not know what length it is, but you know they're equal to each other. And so that's what this is saying right here. Red slashes indicate congruence. So if you see a drawing and they have a little slash through each line, that means they're congruent. Likewise, if you have a drawing and maybe there are several sides that are congruent, you might see one slash and one slash. That means those are congruent to each other. And then you might have another two sides that have two slashes through them, which means those are equal to each other, but they're not equal to the ones with the one. So you can have more than one combination of those slashes. You could have one slash or two slashes or three slashes, however many you need, to tell you that those are congruent to each other. Okay, well, that's it for this time. Appreciate you being here. This is Mr. Anderson, and we will see you next time in Geometry Section 1.3. Bye.